Hello. Good evening, everybody. I'm wait for everybody to come. I'm sure we may not. You have joined for the last 15 minutes or so. You can't keep them waiting, so you have to get it started. All right, so we're going to continue from where we left off yesterday, and it is still on spermatogenesis. So you realize that sperm production goes through a lot of processes. And for that matter, once you have a certain development which involves several processes, then there's bound to be anomaly along the line. And we're going to talk about those anomalies later. But for now, let's look at the norms, the normal thing, the normal development. And as of yesterday, we said that once the sperm has been developed from the germ cell, which is the stem cell, up to the elongated spermatid. Remember, we said that even at the spermatid, that's the final stage of the development, the initial ones are still round. So once it is round, then it cannot be said to be a sperm. So at that point, it goes through the spermiogenesis, where now the cell is no longer dividing, but rather the the organelles within the cytoplasm will now have to undergo some element of metamorphism or metamorphic, or for that matter, transformational changes. We've gone through all those aspects up to the point that we are saying that now the round spermatid has become elongated, which is a semblance of a matured sperm. And you say that the last the sperm will be attached to the Sertoli cells, because we said that the Sertoli cells is actually nurturing or nursing all this development, and therefore the cells which are developing cannot delink itself from the mother unless the mother itself says that, oh, now you are mature, so I'm releasing you. So the final release is the stage we call the spermiation. Now we're saying that once it is now released into the tubule, it is going to go through a series of tubes again, or ducts. And that's where we left off yesterday. All right, so here you are. So for the benefit of those who were not with us yesterday, we'll go through this picture again. Right, so we said that this is first and foremost, the lobules. Within the lobules, we have the seminiferous tubules. And within the seminiferous tubules, that's where the sperms are developing. So once they develop, this is the duct, the panel, or the tube. And because they are small, we use the word tubule. If it's a duct, and if it's a small duct, it's also ductile. Now, so these ducts, and for that matter, small tubes coming from the seminiferous tubules will join. We call that anastomosis. The anastomose, they join together. So you have several of them joining together. As they join together, 10 to 15 of the tubules joining together to give you one of the tubules from the seminiferous side here. So these ones will now be merging together to give you another set of tubes. And this set of tubes is called a red testis. And I kept on emphasizing that red testis is not a tissue. Tubes is the result of the anastomosis, or the combining of the various seminiferous tubules. So from the seminiferous tubules, you get to a red testis. Now the red testis are also smaller tubes that will also be merging, just as these ones merge to give the red testis. The red testis will also be merging to give you another set of tubes or ducts. These ducts are called the efferent ducts, and they have various names, either efferent ducts or efferent ductiles. And I'm saying that efferent ducts and efferent ductiles, the difference is the ULES. And wherever you have ULES as a suffix to any medical terminology, it means little or small. So if you say duct and say this is ductile, you only say that they are small ducts. All right. Now, so if you have a tube and then you have tube, then that would be a small tube. That is all. So whenever you have the ULE or ULES as the suffix, it means small. All right. So an efferent, I said that whenever you see efferent, you can use the E to stand for exit. So efferent duct, it means that a duct or tube which is exiting. So you see that all the tubes emanated from this side and they are now exiting. So this become efferent ducts or efferent ductus or vasa efferentia. And confuse vasa efferentia with passing from the end of the spermatic cord to get to the ejaculatory ducts. So don't confuse vasa deferens with vasa efferentia. Vasa efferentia, yeah, within the tubes. So they are still within the testes. So take note. And they are those ones from the semireferral tubes through the rectum or the initial segment of the face, which is also called the caput. So remember from previous discussion, the epididymis can be divided into three segments. The initial segment is the head, also called the corpus, and then the tail of the epididymis. We're talking about the tail end. Talk about the caput epididymis. So now you know that the sperm can move from the site of the development up to the head of the epididymis. All right. And it doesn't get right from the semireferral tubes to the head of the epididymis. It doesn't do that. It rather pass through some other tubes, namely the red testes, efferent ducts, and then the epididymis. All right. So let's look at the transport system. Sorry, I went off briefly and I'm back. I hope you can see my slides. All right, so you see that spermatozoa removed from the seminiferous tubes, which you call testicular spermatozoa, because they are still within the testicles. Remember, after they move into the epididymis, they are outside the testicles. Through to the vas efferentia, they are still called testicular spermatozoa because the structure, all these structures are within the testicles. Now, and we said that up to this point, they are immotile. They cannot move. All right. So that's why we're saying that even though they are deemed to mature, they are still non-motile. All right, still immature. All right, to move from the tubules up to the what we call it, up to the epididymis, head of the epididymis. All they do is that the testicles or the testes rather provide some fluid. Okay, fluid, and then through contractions like peristaltic movement, the head of the test of the epididymis. So take note that by the time they reach the head of the, there's a lot of fluid because they need a lot of fluid to move them along. I hope that you are getting this because they are immotile. So you need a lot of fluid to move them along. So sperms reach the epididymis with a lot of testicular fluid. All right. Now, so let's look at what the epididymis will do. Now, so we are still on the fact that the epididymis, one of the major functions is to move the sperms from the vas efferent because up to the vas okay. In between, we have the epididymis. The primary function is to transport. All right. Now, it takes about of the epididymis. So see that the first function that is going to transport. Second function is to compare that epididymis. There's a lot of testicles because, like I said, because they cannot move and with that contraction to move them along. So the sperms come to the head of the testes with a lot of fluid, like I said earlier on. So the epithelium lining of the epididymis should absorb all the testicular fluid. Because I don't really you see that when you talk about the testes, these sperms are from the prostate and also so forth and so on. So if there are already a lot of fluid around the sperms, then it means that if they get to the seminal vesicle side, which is also going to produce a lot of fluids, then what is going to happen? Who can tell me? The sperms come to the epididymis with a lot of fluid from the testicles, testicular fluid. So if it doesn't, if the epithelium, epithelium of the epididymis do not absorb, do you think will happen at the end of the day? They are saying that sperms are, and they come along with a lot of testicular fluid. I'm saying that one of the key functions of the epididymis epithelium to absorb all this fluid. I'm saying that if that doesn't happen, what do you think will be the result? Assuming that the epithelium, sorry, the epididymis just allow everything that comes from the testicles to just move along. What do you think will happen? Yes. That's very good. So you see that, and you are very correct. So you see that the sperms are coming in with a lot of fluids, and they are going to go along during the emission and the ejaculation. They are also going to have a lot of fluids from the seminar, and also from prostate. So it means that the fluid content is going to be higher. And once it's going to be higher, what will happen is that the sperm count from the testicles, we don't need them. Otherwise, they are going to dilute the ultimate epididymis does is to absorb all this fluid from the testicles. So testicular fluid is going to be absorbed. So the numbers of the sperm that are coming will be highly concentrated. So that's very, very, very important. So talking about the transport, we're talking about another important role the to actually absorb all the testicular fluid. All right. Another important function, sperm protection. Remember, we said over and over again that one of the things that actually destroys sperms is the ROS. For that matter, oxidative stress. We said that ROS, the reactive oxygen species, if they are normal, the antioxidant capacity of the body, then the resultant effect will be oxidative to the DNA. All right. So once the sperms get to the epididymis, the epididymis will have to produce a lot of antioxidants. Okay, it will have to produce a lot of antioxidants to protect, because after all, the sperms are going to be actually stored in the epididymis. And you know, this ROS, reactive oxygen species, whenever there's inactivity, they will produce. All right. And I'm sure these things, we've talked about it over and over again, that reactive oxygen species are just alterations of the normal oxygen. The normal oxygen in the body, which is useful, is we call it diatomic, double oxygen, O2, the oxygen. That's the normal oxygen the body wants. However, through a lot of activities, that oxygen can become a single O, which we call a singlet oxygen. It can become O3, which we call the superoxide. It can become other products that contain one or two or three different atoms of the oxygen. All these ones are not useful for the body. Okay, they rather harm or damage cells of the body because they are highly reactive. And so you call them a reactive oxygen species. So reactive oxygen species is not one entity. It's a whole lot of oxygen products that are actually dangerous. So once what do you call it? The sperms are going to be stored within the epididymis, and they are now very plentiful. Then the epididymis will have to protect them by producing extra antioxidants so that they can keep the nuclear integrity intact. And one of the known antioxidants that the epididymis will provide or will produce is superoxide dismutase. I'm sure a lot of you, especially those who are chemistry inclined, will know the superoxide dismutase. Superoxide dismutase will convert any of the what do you call it? Reactive oxygen species to hydrogen peroxide. Okay, that's the work of dismutase. Superoxide dismutase will convert any of the reactive oxygen species to hydrogen peroxide. And somebody say, why is hydrogen peroxide also not dangerous for the body? The body also has a lot of catalysts. I'm sure those of you also in microbiology, you know, do the catalyst test. All right, catalyst test is just like hydrogen peroxidase. So the because the body has a lot. What is the peroxidase? The peroxidase is that enzyme. You see that when you have an reactive oxygen species, which is the superoxide dismutase, it will convert it immediately to hydrogen peroxide, and immediately catalyst is available to convert the hydrogen peroxide into water and oxygen. Water and oxygen are now very useful for the body. And so that's how the neutralization effect takes place. So we have a lot of superoxide dismutase within the epididymis, and its function is to convert any excess reactive oxygen species to hydrogen peroxide, which will ultimately be converted to oxygen and water. And by so doing, they will protect the sperm, DNA, and for that matter, chromatin integrity. And that is the protection that the epididymis provide for the sperms. It is very, very important. We also realize that now outside the testes, once the sperms are in the epididymis, they are outside the testes. And we realize that in the testes, sperms are protected by the blood testis barrier. I hope that you remember that. The blood testis barrier are also provided by they are outside the protection. They are outside the protection of the blood testis barrier, and so we now have to now the epididymis will now also have to provide what we call blood epididymis barrier. I hope that you are not confused. within the testis, we have the blood testis barrier. Okay. Now, in the epididymis is outside the testicular structure. And so sperms in the epididymis are not being covered by the blood testis barrier. And so with the epididymis will also have to provide an extra protection by providing blood epididymis barrier that will shield the sperms from the immune system, as the case may be. And I'm hoping that this point is also clear. So epididymis is not just a tube where sperms are just passing through. So at least now you know that there's transport system there, there's concentration system here, and there's also the protection. And this protection, you have two systems. One, the superoxide dismutase protection, which will convert ROS to hydrogen peroxide, and for that matter, neutralizing the harmful effect of the ROS. And then the blood epididymis barrier, which will also prevent any likelihood of immune system attacking the sperms. Then let's look at another protective mechanism of the epididymis. Now you know that the sperm in the epididymis has the head with the acrosome, and we said that the acrosome is made from the Golgi bodies, which contains the hydrolytic enzymes. Okay. Now, the essence is that once the sperm get to their final destination, which is in the female genital tract, and for that matter, going to face the female egg, the ovum will have to be penetrated by the sperm. Once the what do you call it? The sperm gets close to the ovum, the acrosome will have to release its content, which is the what do you call it? The hydrolytic enzymes. This is supposed to now touch the wall of the ovum and break it. Okay. Once that happens, then the sperm can enter. All right. We call this acrosomal reaction, and it's also called a capacitation. If the acrosome do not break to give you this capacitation effect, there's no way the sperm can penetrate into the female ovum. It doesn't happen, right? So that is very important. The acrosomal reaction is where the the acrosome will break and release its enzyme, which are hydrolytic, and then they will just get into a reaction called the capacitation. Now, because the sperms are going to be stored in the epididymis for a long time before they are ejaculated, then the epididymis will ensure that the capacitation reaction do not take place. So it produces what we call decapacitation factors. Yeah, I hope that you are following it. Once the sperms are there, the likelihood of the Golgi bodies, and for that matter, the acrosome breaking to actually stimulate the capacitation reaction is very high. Okay, meanwhile, the capacitation reaction is supposed to take place in the fallopian tube, where the egg is supposed to be meeting the egg, the sperm is supposed to meet the egg, and then now that hydrolytic effect will actually break the covering, or which is called the zona pellucida, the zona pellucida, that's the protective covering of the ovum. This But until it gets there, this reaction should have to be curtailed. And so the epididymis will produce what you call the decapacitation factors to ensure that the acrosomal reaction do not take place. And so this is also a protective mechanism. I hope that that point is also very clear. Then the final sperm maturation process. So you see that within the epididymis, a whole lot of things also happen. A whole lot of things. We talk about the transport, which is the main thing. We talk about the concentration effect. We talk about the protective effect, either using the antioxidants, and then also what we call the the decapacitation effect, and so forth and so on. Now, the sperm maturation. The sperm maturation process required for normal male fertility occurs during epididymal transit. They undergo changes in nuclear compaction, plasma membrane composition, cytoskeletal structure, and protein payload. All that is happening is that within the epididymis, if there is likelihood of the DNA condensation not properly done, this one is taken care of within the epididymis. So within the time, the transit within the epididymis, other changes or cytoskeletal changes take place within the epididymis. And so if the nucleus is not well positioned, that adjustment will be made. I'm sure you know how to protein payload. I mean, if there's some proteins which are not going to be necessary for the upkeep of the listen, they'll also be taken off from the listen. If there's any membrane structure which is not very required for the for fertilization, also to speak, to enhance fertilization, all of them will be taken care of. And so this element of maturation process also taking place within the epididymis. So a whole lot of things can happen within the epididymis. So it becomes a target for andrologists, clinical andrologists, where they can now go into the epididymis and then see whether they can retrieve sperms that can be used for artificial insemination, and for that matter, artificial reproductive technology. All right. I hope that you have followed. Right. So the last aspect within the epididymis is the acquisition of sperm motility. We realize that the sperm will have to motile. And we said that from the testicles, the sperms are immotile. They are not motile. All right. So you realize that they will learn to move within the epididymis. You will see that the whole epididymis is very winding, very winding. And so as the sperms are moved along the coil and with that winding form, it's like a training ground for the sperms to learn how to move. And I'm sure this one you can just experience it. If a child is learning how to walk, I'm sure you see that the mother will be putting some wheel of a sort, and then you'll be turning round. And with time, once the wheel is not there, you see that the child is able to move along that side. So the winding effect of the epididymis and the fact that the sperms are moving along that side, it gives them a ground for exercising. Let me put it that way. And so by the time they get to the caudal or the tail end, they will have acquired the capacity to swim or to be motile, so to speak. So that is the final end of the maturation process in the epididymis. So by the time spermatozoa reach the caudal, and I'm sure we know the caudal, that's the tail end, epididymis, a majority of cells are capable of progressive motility. Although sperm develop the capability of motility, several inhibitory proteins in the epididymal fluid still prevent final motility until after ejaculation. This is very, very, very important. Just as we said, with respect to the capacitation, the epididymis will ensure that they produce factors that will inhibit the capacitation, or for that matter, autosomal reaction to take place. Similarly, by the time the what do you call it? The sperms reach the tail end. All right. By the time they reach the tail end, they will have learned how to swim. And for that matter, they will learn how to move. However, there are also other factors that are produced by the epididymis to ensure that they don't move. Otherwise, there will be a lot of movement all over, and then there will be stampede. Okay. So the sperms will have gotten to the end or the caudal, or for that matter, the tail segment of the epididymis. They have the capacity to move or to motile, yet they are inhibited. They are restricted from moving until after ejaculation. That's where the movement will take place. And then again, the sperm storage. Functionally mature sperm cells are stored in the caudal, and for that matter, the tail region of the epididymis prior to ejaculation. While paired caudal, when you talk about paired caudal, you're talking about the epididymis. We have two of them. It's a paired epididymis. The tail end will become two, so it's a paired caudal. Can accommodate sufficient sperm for a number of ejaculates. All right. What it means is that in the tail end, you have millions of sperms which will be stored. And the fact that if you want to have ejaculation every day for the next 2-3 days, you can still get some sperms in there. However, after each ejaculation, the number will necessarily reduce. Okay. So that's how it is. If there's no ejaculation for 6 to 10 days, sperm will spill into the prostatic urethra and avoided into the urine. So occasionally you do some urine examination, urine deposits, and then you see sperm in the urine. So all it means that a person may have had abstain from sex for too long a time. If you abstain too long a time, you know the sperms are stored, and if there's every day sperms are being produced. We have millions of sperms that are produced every day, and they are all being stored there. So if for a long time you are not listening, it's like automatically some of them will spill over and then get into the vasa deferens, and then into the ejaculatory duct, and then into the urethra, and into the sperms, sorry, into the urine. Called spermatoria. That's finding sperms in the urine. It's a normal thing. Okay. All right. So we are having an overview of the spermatogenesis. An overview. So that you can actually recollect all that we said. So within the seminiferous tubules, for each tube, there's a basement membrane. Okay. And the basement membrane contains the germ cells. This one you know already. And we said that germ cells will also become the stem cells. And this is the spermatogonium. All right, so you have a spermatogonium. So in actual fact, the germ cells are undifferentiated cells, as you have for hematology. You have the pluripotent stem cells that is undifferentiated. Okay, unless you receive a signal to produce, let's say, myeloid cells, then you move along that line. So you may receive a signal to produce sperm cells. That is where the basement membrane germ cells will begin to produce the spermatogonium. Then spermatogonium, as we said already, will undergo mitosis to produce primary spermatocytes. At the end of the primary spermatocytes, here, some of the sperms will go back to form parts of the spermatogonium, for that matter, the stem cells. And that is where you have the fate decision. Some will also go through the the meiosis. In meiosis, you have meiosis 1, meiosis 2. So meiosis, the first meiosis was from the primary spermatocyte to the secondary spermatocyte. And then the secondary spermatocyte will also undergo meiosis 2 to produce spermatid. This spermatid, the initial ones are round. So we call them round spermatid. And then after the round spermatid, they will go to the spermiogenesis. Spermiogenesis, where this one will now go through cytological changes and then become elongated spermatozoa. All right, so I'm sure it's very simple for anybody to follow it now. So it's the same thing here. So this, your seminiferous tubules, a cross section of the seminiferous tubules. Okay, so you have the germ cells. And the important thing that we want to demonstrate here that if this is the seminiferous tubules, this becomes your basement membrane. Okay, and then you see that the lumen is here. The lumen is here. So you have the basement membrane, and then as you are moving along, the germ cells will be developing from here, until they get here. All right. So as you are moving from this side to this end here, you're only going to get spermatogonia, and for that matter, what do you call it? The germ cells. As you are moving along here, you may get cells that are becoming spermatocytes. As you are getting here, sperms are becoming spermatid. As you are getting here, they become the elongated spermatid. And then through spermiation, they get into the lumen. So this is, if you take this one as the larger portion of this one, then you see that the seminiferous tubules, this is a section of the epithelium. All right. So you have the spermatogonia at the basement here. This is your Sertoli cell, which is guiding the development of the cell. So one Sertoli cell is taking care of several of the, germ cells. Okay. So you have here as your Sertoli cell, you have germ cells here, you have germ cells here, and they are development. They are all being guided by the Sertoli cell. So as we move along, we are going to look at what we call the germ cell Sertoli cell ratio. So if there are too much of the Sertoli cells, too much of the germ cells which are being produced, then some cannot be taken care of. So some will automatically be tagged to die. And then we are going to look at apoptosis. So this is, in simple terms, the whole element of spermatogenesis. So look here, I just want you to, this is the seminiferous tubules. So here, if it is under seminiferous tubule, this becomes interstitial space. I hope that you can remember. And within the interstitial space, you are going to have your Leydig cells, the LC. the Leydig cells will be here. Leydig cells are within this is the interstitial, not so they're outside the tubule, interstitial. So you have the Leydig cells. You are going to have macrophages. Macrophages, because this space, you can have blood cells here. But you cannot have blood cells here because of what? I'm saying that within the interstitial space, you can have blood here. But you cannot get blood here. Why? Anybody? If you look at this, I'm saying that this is the interstitial space. Over here, you have Leydig cells. You can also have blood cells here. But you cannot have blood cells in here. Why? There's somebody to try for me. Within the interstitial space, you can have blood here. That's why you have macrophages. And you have dendritic cells. Okay? All here within this space. Then you cannot have blood or dendritic cells here. Why? Somebody should try for me. You should know this. Yes, who is coming? Oti, Martin, they're good at this. You have this as your seminiferous tubules. You have under seminiferous tubules. You have, so within them, you have the interstitial space. I'm saying that within the interstitial space, you can have blood cells. And therefore, you can also have macrophages and dendritic cells. I'm sure you know macrophages and dendritic cells. I'm saying that all these can be the interstitial cells, the interstitial space, but not here. Why? Somebody should try it, please. I hope you're not sleeping.
I know.
So what? Yes, because this space, you have
There's a barrier, grandpa.
yes, you have the blood testis barrier here, provided by the seminiferous tubules. So provided by the Sertoli cells. So
Yes.
blood cannot go here. But you have this space, there is no barrier. So you can have blood circulating here, and we have macrophages and you have dendritic cells. What's the difference between macrophages and dendritic cells? Some small immunology. You know dendritic cells? Yes, who can help us? The LC here is the Leydig cells. DC is dendritic cells. M here is the macrophages. Good. So over here, because you have blood that can circulate within the interstitial space, it means that you can have all the blood cells there, macrophages that can pick up any macromolecules. Okay. And dendritic cells are there as APC, antigen presenting cells. So if you have a macromolecule, they will first and foremost be attacked by the dendritic cells, which will present them to the immune system for them to be taken up. All right. But you see that over here, within the seminiferous tubules, you don't have macrophages You don't have anything here. So the Sertoli cells will play the role of the macrophages. When we get there, you see how that happens. So that if there's anything here which has to be, macrophages, they take out macromolecules by what process? By what mechanism does macrophages take up macromolecules? Yes, somebody should tell me. By what mechanism does macrophages take up macromolecules or antigens?
So is it phagocytosis?
Fantastic. Who is speaking? Is that Hannah?
Vera, please.
Vera. Oh, that's good
Yes,
for you.
sir.
My Vera, thank you. So to
Thank you.
phagocytosis. So, and I'm saying here that here we don't have macrophages here. But as we move along, you see that the Sertoli cells will play the role of macrophages. And in playing the role of macrophages, it means that if there are dead cells here, the Sertoli cells will have to phagocytize them, will have to pick them up through phagocytosis because they are playing the role of macrophages. Macrophages pick up macromolecules by phagocytosis. And that is what is going to happen here. So please, I want you to understand all that we are doing with the science that is behind it so that you yourself you realize that you know your stuff. All right. So we move on. If you look at the epithelium of the seminiferous tubules, we have two compartments. We have the basement side, and then the side which is close to the lumen. I'm sure you know the lumen, the space. The side which is close to the space, to the lumen is called adluminar, like paraluminar, or adjacent to the lumen. So if you take this as the epithelium of the seminiferous tubules, it can be divided into two compartments. All right, just as the whole testicles can be divided into two compartments. One compartment is the seminiferous tubules. The other compartment is the interstitial space. Okay. When we come to the epithelium here, we have the basal compartment. So within the basal compartment, you will never get mature sperms here. All right. Within the basal compartment, you will never get, because within the basal compartment, you only have the germ cells which are beginning to develop to give you the spermatogonium and then the spermatocytes. That's all. And as we are moving towards the lumen, then the spermatocytes will have developed into round spermates and become elongated spermates. So if you are, let's say in histopathology, and you do testicular biopsy, and then the pathologist is looking at it, that's the principle that they are going to use. So if at this point you are not getting the basal compartment here, if you have done your H&E, and for that matter, done your sections, and the pathologist is looking at it, you know this is the tubule. If this is the tubule, you have your lumen here. You want to see whether you are going to have elongated spermates along the side. He's not going to look here for elongated spermates. You see, because here you are the basement membrane, and at the basement membrane, all you have are what? Spermatogonia and then spermatocytes. So you are going to look for sperm cells at the adluminal side, the side which is close to the lumen. That's all that they do. So if along this side you are not seeing mature, so you are not seeing any spermatogonia, then there's an arrest. You are going to look at what we call maturation arrest. So here you are expecting to get the spermatocytes. So you are not getting spermatocytes here. So it means that there has been an arrest. There has been a termination of the developmental stage. And that is what the pathologists, and for that matter, you as scientists, should know. That how will they diagnose maturational arrest? and even maturation arrest. You have early maturation arrest and late maturation arrest. What does it mean? We are going to talk about all these things, but I want you to get this concept that within the structure, you are going to have the section of the seminiferous tubules. This is the epithelium of it. Within the epithelium of the seminiferous tubules, the first compartment here is basement or basal compartment. Over here, you will never see round or mature spermatids. You will never see them here because the development is starting from the germ cells here, and they are developing, and going up. So here you are only going to look, you are going to see spermatogonia here, you are going to see spermatogonia and then spermatocytes. Spermatocytes 1, spermatocyte 2, and then spermatid, which is at the adluminal section. All right. I hope that you are following it and you appreciate it. So the seminiferous epithelium is divided into two compartments, as we said, the basal compartment and then the adluminal compartments. Adluminal is those lumen, that's the hole, adjacent to the hole. So that's adluminal compartment. And then just at the basal compartment, you are going to have the germ cells. Sometimes we call it primordial germ cells. They are the undifferentiated spermatogonal cells at the basement membrane. And then they will progress gradually and up to where we have the adluminal compartment, as I explained in the previous slide. So more of it here. The different developmental stages of the sperm. So here becomes your basement membrane, or basement compartment, or basal compartment. And then here you are going to have spermatogonia. As you move along, you are going to have, this is describing the blood testis barrier, because this is a Sertoli cell and this is also a Sertoli cell. In between Sertoli cell, there will be a bridge. So this is the diagram that's talking about the BTB, the blood testis barrier. But we are talking about where the sperm is developing from the basal compartment here up to the lumen here. All right. As I've talked about, initially you have the germ cells, you have the spermatogonia, you have the primary spermatocytes here, you have the secondary spermatocytes, you have the round spermatocytes, the round spermatids, and then the elongated spermatids. Like I've said over again, for the benefit of those who are in histology, if you do testicular biopsy, okay, a biopsy of the testis. This is exactly how diagnoses are made. All right. So still as overview of all that you are doing, some keynotes. So spermatogenesis processes can be classified into spermatogonium mitosis. I'm sure you appreciate this. This is an overview, okay, and the key points. So from the germ cells, you develop into spermatogonium, and at the spermatogonium, it will undergo mitosis. So I want you to appreciate some of the terminologies so that once you read elsewhere or somebody mentions it, you can just understand what it is. So the spermatogonium, which is developed from the germ cells, will undergo mitosis. So you call it spermatogonium mitosis. You can also describe it as spermatogonia proliferation, because if cells undergo mitosis, what happens? They will divide into two identical cells, and therefore they are proliferating. So spermatogonia proliferation is still talking about mitosis. And remember, we said that at that point, some of the cells will go back to form a pool, to form part of the pool of the stem cells. And that is the element of stem cells or characteristics of stem cells, which we call self-renewal. I'm sure this thing is also well known to you. So at the spermatogonial mitosis, we describe it as spermatogonial proliferation or self-renewal. Then from there, we go to spermatocyte meiosis. Spermatocyte meiosis. From there, we go to spermatid morphogenesis. I'm just bringing some of these terminologies out so that whichever way you meet them or wherever you meet them, you are not confused. The same thing that we talked over and over again. Spermatid, I'm sure you remember spermatidogenesis, where spermatocytes will transform into spermatid. All right. And we said that with a spermatid, there is differentiation into mature spermatozoa. The differentiation takes place within the cytoplasm. And I'm sure this is what we call spermiogenesis. All right. We've said that the mechanism where some of the cells will go back to form part of the stem cells, and where some also will progress to become mature sperms, is called fate decision. I'm sure you remember. These things are just a recap of all that we've done. So by fate decision, spermatogonia will self-renew or differentiate to produce the male germ cells. So still on the keynotes, primary spermatocytes are produced by mitotic division of spermatogonia. So you realize that from the spermatogonia, it will undergo mitosis to give you primary spermatocytes. And that is the end. After primary spermatocytes, the next line is meiosis. Okay. After the primary spermatocytes, it doesn't divide by mitosis again. It will rather develop by meiosis. Okay. So after meiosis 1, you have 2 secondary spermatocytes. All right. And then after meiosis 2, the cells become round spermatids. These are all just recap of what you have done. So with spermiogenesis, this is the maturation process by which the round spermatids become elongated spermatids. You know this thing too already. And we said that during spermiogenesis, 1, there are no cellular division. You don't have cells dividing again. However, the nucleus that become condensed and migrate to an eccentric position. Then you have the Golgi apparatus also surrounding the nucleus to form the acrosome. These are all things we know already, and just a recap. There's something important here I want you to take note. Now, it said that sometimes there could be a poor packaging of the DNA. Now, when there's poor packaging of the DNA, there's potentially a decrease in fertility potential. Right. Here, we are talking about the spermiogenesis, where at that point, the cell itself is supposed to undergo metamorphic changes and then move the nucleus to one side and so forth. There could be an interruption in that process. All right. And so the DNA, instead of condensing and packing tightly, may be losing. That may not necessarily be due to an ROS. It's just by structural deformity. So that can happen. Right. Now, we also said that the Golgi bodies will have to also move to surround the nuclear chromatin, and for that matter, the DNA. Now it will have to cover it. Now in covering it, there's supposed to be a protein that will bind or that will link the nucleus and the cap. I just want you to imagine it. We have the nucleus, which is moving to one end, and then the nuclear chromatin is condensing or is packing. And then you have the Golgi apparatus coming in to cover it. Once you cover it, there should be something like a link, a certain protein that will now link the chromatin and then the what do you call it? The Golgi body, which is covering it. Otherwise, if it doesn't cover it, if it doesn't link it, it then makes it like some loose cover, which can move away at any time. I hope that you are getting that point. That protein is called DPY19L2 protein. Okay, so that if for any reason an individual lacks that protein, then it means that the acrosome, the Golgi bodies, which is going to cover the nucleus, and for that matter, the chromatin, there's nothing to link it, to anchor it. Okay, once that happens, then it will make the what do you call it? The shape of the head of the nucleus. So the shape of the head of the sperm look rounded. Okay, it makes it look rounded, and it forms what we call globospermia. You know a globe. I'm sure all of us, even for primary school, if you go to a headmaster's office, there's always a globe, some round thing that with a word map on it. So that's a globe. So a globe is something which is rounded. So a sperm which has a round head is called globospermia. I hope that point is clear. And there's here, it is where there's a deficiency in a protein called DPY19L2 protein, which is supposed to anchor or to link the Golgi bodies with the DNA. Sorry, with the DNA, or for that matter, the nuclear chromatin. If there is nothing to link it, to anchor it, then the head becomes rounded. All right. Thank you so much. Then with the spermiogenesis, you know already, you said that the tail arises from the central, and then it is the mitochondria that will also form the neck or mid piece. Now, excess of cytoplasm containing the remnants of Golgi apparatus and other organelles form what is known as residual bodies, which are phagocytized from spermatids by Sertoli cells. What it means here is that we are talking about a stage where the round sperm is configuring itself to become elongated spermatozoa. There are certain organelles within the body, so within the cytoplasm, which may not be necessary as the sperm is being formed. All right. Those remnants are collectively called residual bodies. Those remnants are collectively called residual bodies. And it is the responsibility of the Sertoli cells to pick them up, to take them up to phagocytosis. Okay, good. Right. This is another important point. I've said it already. So throughout spermatogenesis, from the early developmental stages up to the elongated spermatids, the cells are still tied to the Sertoli cells. I'm sure I've explained this already, because they are being nursed at every stage of the development. They must be attached to the Sertoli cells. All right. So it is only after completion of the formation where the Sertoli cells will release the sperm into the lumen in a process called spermiation. I'm sure we have said this over and over again. This step is FSH and testosterone dependent. This stage is dependent on FSH and testosterone. So if you run out or you have low FSH and low testosterone, then you could end up getting low sperm count because the sperms which have been formed are still attached to the Sertoli cells because they have to be released into the lumen for them to now go into the red testes and to the vasa efferential to the head of the epididymis and then go up to the end or the corda of the epididymis and be stored. If they are not being released, it means a lot of mature sperms will be still attached onto the Sertoli cells. All right. So that's where sometimes if there's low sperm count and everything, if they do testicular biopsies, they can look at all these things. You have a lot of mature sperm cells still attached to the Sertoli cells. That means that you have to go and do hormonal analysis. You go do hormonal analysis, you see that we have low testosterone, low FSH. Then they will tell you that. So if that's the case, then you can look out for what's accounting for the low FSH and then the low testosterone. And yesterday, when we were talking about the effect of obesity, we said that in obesity, there's the aromatase enzyme, which are produced from adipose tissue. So adipose tissue will convert, the aromatase enzymes will convert testosterone to estrogen. Now you see that in the sperm production, we don't need estrogen. All right. However, the testosterone have been converted to estrogen. So estrogen now become counterproductive. And by which time it will serve as a negative feedback on the hypothalamus. So hypothalamus will also reduce the quantity of the gonadotropin releasing hormones. And then once it comes to the pituitary will also now reduce the number of FSH and this, and then the cycle will continue. All right. So you could, when you do testicular biopsy and then they report that there are a lot of mature cells that are stuck onto the Sertoli cells, then you could explain, you can look at the other factors. All right. Thank you. So you move on. So we are going to look at an important phenomenon called apoptosis in spermatogenesis. Apoptosis in spermatogenesis. Yesterday I mentioned it, and somebody rightly said apoptosis is programmed cell death. And programmed cell death is different from apoptosis, is different from necrosis. Necrosis, the cells are already dead. Apoptosis, there is a signal on the cell that this cell will not live long. Okay, this cell will not live long. So it is bound to die. That's apoptotic cell. Now, we've said that, so let's move per the slide and you appreciate it. More than 100 million sperms are produced each day in men during their whole reproductive age. That every day of a man's life, you are having 100 million sperm being produced each day, more than that, every day. All right. Since a large number of germ cells develop simultaneously within the seminiferous epithelium, and since the number of germ cells that Sertoli cells can support for finalizing their development is limited, there is competition for space and nutrients. I hope that point is clear. You're saying that now, every day, there are millions of sperm that are produced, and they are starting from the germ cells. And you're saying that with the germ cells, initially it's mitotic. So the cells are divided into two. And then the two also divide into other two. The two also divide into two. So several things are happening. And meanwhile, they are all being supported by Sertoli cells. So I'm sorry, I had a little distraction from my small boy. So you're having millions of germ cells that are developing per second and per minute. Meanwhile, they are all being supported by Sertoli cells. And so you see that, yes, it is good that some of them will go back. Remember, we said that at the fate decision stage, some of the cells will go back to form part of the stem cells. Okay, the spermatogonial stem cells. I hope you remember this. And then some will also move on. But the number of cells that are supposed to develop, they are all being guarded by Sertoli. And Sertoli cells, they don't reproduce. Yes, that you are getting me. The Sertoli cells are constant. They are not reproducing, but the germ cells are reproducing. And they are all being supported by the Sertoli cells, which number is constant. So what it means is that there'll be competition for space and nutrients. The nutrients are being provided by the Sertoli cells. You remember this, because they are the nesting cells. They are providing, and their numbers are constant. And then the germ cells are producing overall, every second they are dividing. And so they'll be overwhelmed by the number of germ cells that they have to take care of. Therefore, automatically, there's going to be like competition for space. And it's like when you have a dog that is giving birth to, let's say, 10 puppies, 10. Meanwhile, sometimes the available, what do you call it, nipple, may be just about 6 or so. So you see that you see what will happen. I'm sure some of you may have observed this phenomenon before, where you have a dog. If a dog has given birth to, let's say, 2 puppies or whatever, then I'm sure at any particular point in time, everyone can get access to the breast milk. But if you're giving birth to 10 and the nipples are just about 6, then you can imagine there will always be fight for space and also fight for breast milk. So that's exactly what is happening within the lumen. So there is competition for space and nutrients. Necessarily, some are bound to die. So you realize that if you have to go critically to the phenomenon we described earlier, that when the cells divide, they either will go to self-renewal or they will progress to become mature cells. You realize that that sentence is not entirely true. If you say that, it means that once some will go into the pool for the what do you call it, stem cells, and then the rest will also develop to become what do you call it, develop to become mature sperm cells. That statement is not entirely true, because that portion, a lot of them will also die. So it is either you go back to the stem cells for cell renewal, or you mature, you go through the maturation and become mature sperm cells, or what? Or what? Hello, I hope you are following the discussion. The fate decision stage, we said that the cells will be dividing, and then some will go through failed decision, some will go back into self-renewal, and the rest will also now move to develop to become mature cells. I'm saying that now at this point, we see that that statement is not true. Rather, some will move into the stem cells, some will mature, and some will also do what? Hello? This is simple. I want an answer. Some will also do what? Talking about spermatogenesis, the developmental stages. Some will die. Thank you, Clifford. Some will necessarily die. And in fact, majority will rather die. Majority will die off. All right, good. So, and I'm sure you can explain why they will die. Because of the struggle, and even there will be like stampede. Okay, because everybody wants to, the rest which are supposed to develop to become mature cells, everybody wants to attach to the sartorial cells so that they can be fed. So there could be a struggle. That struggle, within that struggle, some will die. And then some will be underfed, and as they are underfed, they also die. Some will also suffocate, and a whole lot of things. So, in effect, yes, majority will die. That's good. So you are getting it. So, and that death is not like immediately death, but you will see that, oh, you are being underfed. So you yourself, you know that, oh, you will not survive for long. Okay, so that's what we call programmed cell death, and that's apoptosis. Apoptosis is not like you are dead, but you are bound to die. You are bound to die. All right. So that is another phenomenon in spermatogenesis. So up to 75% of developing germ cells or spermatogonia are discarded through the process of apoptosis. So you see that the number which will be discarded or will be dropped along the line is far, far, far more than what will actually progress to become true sperm cells. These are the facts that we should know. And scientifically, I'm sure you can explain, right, that the number of sertoli cells are constant. The germ cells are being produced through mitosis. They are dividing plenty. And remember that when we have one producing two, the two become four, the four become 16, and that kind of this thing. You understand? Except that some of them will go back to failed decision to form part of the stem cell so that the system will keep on running. But the rest that are also coming to develop, like we said over again, they are too much for the sertoli cells to support. They are so much. And to the extent that up to about 75% of them will necessarily have to die. And that is the process of apoptosis. So we call them spermatogonia apoptosis. Okay. And it is supposed to be a vital mechanism to control the overproduction of sperm, as well as maintenance of the germ cell sertoli cell ratio in the testes. So you see that it is even important, it is necessary that some will have to die. Because like we know, if you don't do that, the sperm production, they are just too much. And remember that they are all going to be stored in the test in the caudal epididymis. And you see that there will be no space even to store them. So the spermatogonia apoptosis is like a necessary evil. Okay, it's a necessary evil so that you don't have too much sperm being produced, because too much sperm being produced is also a problem, can also be problematic. All right, so spermatogonia apoptosis is a vital mechanism to control the production of sperms. If all of the sperms should have been seen through to production, to the maturity, there will be no space to even contain them. All right. So I'm sure you also appreciate the fact that the Sertoli cells are not reproducing. The Sertoli cell number is constant. Therefore, there should be a certain number of germ cells which are being developed. There's a certain number that can be supported by the Sertoli cells. So that's that number may have to be constant. So the rest will have to die. So the apoptosis is also ensuring that the germ cell Sertoli cell ratio remains constant. Okay, I'm sure that point is also well noted. So low level of FSH increases germ cell apoptosis. Okay, so FSH is very, very, very vital. Remember, we said that FSH is also required for spermiation, the process where sperms, the mature sperms, will finally be released into the lumen. All right, and so if FSH is low, then spermiation will also be reduced. We have also now learned that if FSH is also low, it increases the number of sperm cells that will have to die. So it increases the apoptosis rate. And so these two combined will result in rather significantly low sperm count. All right. That's why if you have low sperm count, one of the first hormonal analysis to do is to check for FSH. If your FSH is low, straight away it tells you a lot of stories. All right. So when the cytoplasmic portions of elongated spermatids are shed as residual bodies, I've said this already, that when we have the cell which is round with the nucleus moving here, chromatin, mitochondria, other organelles which are not important, they are called residual bodies. All right. The cells will have to pick them up or mop them through phagocytosis. So Sertoli cells at this point will act as macrophages. That's why we said that when you have within the interstitial space, you have blood there, blood can flow there because there is no, the Sertoli cell, which is forming the blood tissue barrier, does not include the interstitial space. And so blood will flow through the interstitial space. And therefore you have macrophages there. So if you have any debris, and anything which is unwanted, then macrophages will pick them up. However, within the seminiferous tubules, because of the blood tissue barrier created by the Sertoli cells, then they don't have macrophages. Meanwhile, look at the number of cells that you're talking about. A lot of them are going to die. And if they are going to die, would they have to be left within the space? If they are to be left within then they will choke the tubule. They will choke it. So all the debris, all the dead cells, and even after the cells have been formed, remember we said that the unwanted remnants, which you call residual bodies, will also have to be picked up. So Sertoli cells have a lot of work to do. So they will mop up all this. They'll take up and clear all the apoptotic cells. Those cells which have actually died and those cells which are bound to die. So, and the residual bodies, they are all going to be mopped up through phagocytosis by the Sertoli cells. So that is very, very, very important. Remember, if let's say you have when you take us back to your hematology, you learn that when cells are aging, okay, when red cells are aging, they become like ovalocized. Instead of being biconcave, they become oval. And as they move through the spleen, through the the splenic, they are picked up by macrophages. Okay, so if cells become oval, it becomes a signal for apoptosis. It's like, even though they are not dead, but once they become oval, the body will see it as an abnormal cell to have to pick it up. Okay. So that is apoptosis. And once you should be able to differentiate between the dead ones, those who are actually dead, and those that possess signals that indicate that they have to die. And they include, let's say, DNA fragmentation. If the DNA packaging condensation did not take place properly, they have no business being developed or being nursed to become mature cells. So some of those things become target for apoptosis. So the body will see it as apoptotic. Those that are also attacked by the oxidative stress, they are also, once they are attacked by oxidative stress, the DNA, it becomes compromised. They become target for apoptosis. So a lot of other things will happen that will send a signal to the body that these cells, they are not correct. So take them up. That is part of apoptotic cells. All those cells and those who have actually died, and then the residual bodies, which we talk about, the remnants that are left by virtue of the round cell developing to become the elongated cells. All those things, the Sertoli cells have the duty to clear them. And as they clear them, they are now behaving as their macrophages. That's why we say that Sertoli cells behave like macrophages. Sometimes we call them scavengers. That's they are clearing up debris. They are clearing up the debris from the. Otherwise, the lumen will get choked. And so these are very, very important scientific reasons that you should appreciate. The elimination of apoptotic germ cells and residual bodies by Sertoli cells is important to ensure enough spaces for a healthy germ cell development and maintain testicular homeostasis for normal spermatogenesis. I hope that point is clear. That if the Sertoli cells clear the unwanted apoptotic cells, and then the residual, they clear them out, it makes the place healthy. Otherwise, like I've said earlier, the place will be choked. And therefore, even those who are actually going to go through the normal development have a problem. Okay, so this elimination mechanism by the Sertoli cells will make the environment clear and more or less clean and suitable for those who are supposed to undergo the development stages to do so smoothly. Okay, I hope that point is also very clear. Right. So at this point, if there's any question, please ask, because we are moving to another area which is a little bit confusing. Okay. If there's any question to ask, please do so. So we talk about the apoptosis in spermatogenesis. We talk about maturation arrest in spermatogenesis. Spermatogenesis, you know already, is the sperm development from the germ cell stage through the spermatogonium, through spermatocytes, through the spermatids to become mature cells. That's the spermatogenesis. There could be an arrest, a termination of the process. That's different from the apoptosis. Apoptosis, we are saying that the numbers that are being churned out per second, per minute are so much that will overwhelm the capacity of the Sertoli cells to nurse. Remember that the development are being nursed up. Yes, they are being nursed. by Sertoli cells. The Sertoli numbers are constant. So if they are becoming, if the cells that are coming in are too much, then they must concentrate on the few that they can feed and allow the rest to die. Okay, that is apoptosis. And we said that it is important in several reasons. That it's important to be keeping the Sertoli cell and then the germ cell populations or the ratio constant. All right. So, and we said that it doesn't happen in vacuum. The same Sertoli cells will ensure that those who are dying or who are bound to die will be mopped up through phagocytosis, so that they will give a clear environment for those who are actually fortunate to be maturing, to actually do the maturation comfortably. That is apoptosis. And we said that the entire cells, up to about 75% of them, will be discarded through apoptosis. And we've explained why that is important. That's apoptosis. We are moving into another stage, which is maturation arrest. And I want people confuse maturation with apoptosis. I want you to understand apoptosis proper. And then we go to maturation arrest. If there's anything at this point which is confusing, please let me know. Apoptosis, very important. And then remember, we said that right from the initial stages, we said that, when the cells are developing, they have two options: either to go back for self-renewal or to actually proceed to develop to become the mature cells. It's like when you are in primary school, early stages, they say, 3 minus 5 is impossible. Then when you are aging, you know that 3 minus 5 is not impossible, it's something. So initially, we tell you that when the cells are developing, there are two options. Either they go to self-renewal or develop to become mature cells. Then at this point, we said that, no, that's not entirely true. Yes, some will go to self-renewal, but those who are even supposed to mature, up to about 75% of them will be tagged to die. And that's the approach. So it means that now the options are no more two, the options are three. That you either go for self-renewal or you go through to maturation stages, or you die. And rather, the or you die proportion cry is more up to about 75%. So, and I think up to this point, I'm sure nobody should get confused. All right. So the maturation arrest. Matogenesis may be interrupted at any stage of sperm development. And this interruption is an arrest. Okay. Now, maturation arrest of spermatogenesis refers to the germ cells that fail to complete maturation. Remember, we said that you can have some of the cells dying. Once you are dying, you have died. I mean, that one you don't count to. Once you go back to self-renewal, you've gone to self-renewal. But if you choose the path of going to be developed to become mature, and along the line, there's also an interruption, that is not apoptosis. That is where I've said that I know many people who always confuse apoptosis and maturation arrest. Maturation arrest, we are talking about that third line, which are supposed to now comfortably go through the developmental stages up to maturity. But within that line, there's also an interruption. That is a maturation arrest. I hope you have understood me correct. So there's a failure to mature, to maturity, that's all. Or can be explained as the interruption of sperm development before the final stage without impairment of Sertoli or Leydig cells. So here you have every opportunity to develop to maturity. The Sertoli cells are there for you. Lady cells are there for you. Of course, lady cells, they are not directly involved in cell development, but they are indirectly involved because they will produce the testosterone, which will now also feed the Sertoli cells for the developmental stages. Here you are saying that your lady cells are functioning, Sertoli cells are functioning, yet there is an interruption in the process of development. Right. So failure of the germ cell to develop further than the spermatogonial stage leads to azoospermia. So here you are saying that, remember that for the germ cells, you move to spermatogonial, then from spermatogonial to the spermatocytes. This process didn't go through, didn't even pass beyond the spermatogonial stage. Okay, they think that this person will be azoospermic for life. That one, there's nothing you can do. That the cells are dividing. Immediately, just after the first stage of dividing, they don't proceed. They, for whatever reason, they are not able to go any further. And so if you do a testicular biopsy for histology, and all you see will be what? Germ cells and then spermatogonial cells. You are not going to get spermatocytes. You are not going to get spermatids. Remember, we said that if you look at the epithelium of the tubules, you have the basal compartment and then the adrenal, your germ cells, then the spermatogonial cells. And then as you move beyond, you are going to see the spermatocytes. If you do this histology, and all you are seeing are just the germ cells, the maximum spermatogonial cells, nothing again. This is what we call early maturation arrest. And this is medically termed as Sertoli cell only syndrome. Sertoli cell only syndrome. I'm sure some of you may have heard it before. You do histology, and then the report come out as Sertoli cell only syndrome. This person, there's nothing that can be done to help the person. It's azoospermic for life. No, I mean, the cells are not developing even beyond the first stage. So what can you do? So that person is totally and absolutely azoospermic. As you move along, you're going to talk about obstructive azoospermia and non-obstructive. This one, there's nothing like, there's no obstruction nowhere. Okay, so that is the pathologist will describe it as Sertoli cell only syndrome. So if you are a student of seminology, you look at somebody's histological report, they have written Sertoli cell only syndrome. You should be able to understand very, very well, far better than anybody. That knowing that under the histological report, they only saw germ cells and maximum spermatogonial cells, no more, no less. All right. And this is a maturation arrest. Spermatogenic arrest, spermatogenic, that is the process of development. Arrest can be due to gonadotropin insufficiency or after germ cell damage due to chemotherapy or radiotherapy. What we are saying here is that if somebody has been exposed to chemotherapy, and especially some cancers of a sort, the chemotherapy that they undergo destroy a lot of germ cells. That's why I'm sure a lot of people undergo chemotherapy and you get a lot of challenges. they are always having anemia because the chemicals will try to destroy the hematopoietic cells, the stem cells for blood development, and therefore the germ cells of the within the seminiferous tubules. And once they have been destroyed, what it means is that they cannot divide. Even if they divide one, they cannot divide again. Okay. Now we can have what we call reversible arrest. Reversible arrest can be due to heat, infections, hormonal or nutritional factors. If somebody is not producing sperm because of heat, okay, and we know the effect of heat on spermatogenesis, then that is going to also cause maturation arrest to some extent. But you see that if now this person has been advised to avoid the risks of the heat, then it means that once it's now going to position the testicles in the right condition, you should have normal resumption of spermatogenesis. So you see that there was an arrest, but the factor is becoming has been removed, and therefore the situation becomes reversible. So that's reversible arrest. Irreversible arrest is where you're talking about if, let's say, there is chemotherapy. If you have chemotherapy and it's destroying the germ cells, that one becomes almost irreversible. If there's also some chromosomal abnormalities, okay, that's causing the arrest in the cell development, then that also becomes irreversible. So you can have maturation arrest whose cause can be transient or can be removed, and therefore the situation can be reactivated, it becomes reversible. Those that are irreversible, we're talking about those that are actually destroying the spermatogonia and for that matter the germ cells completely due to either genetic challenge, so forth and so on. All right, so those are some of the things that as scientists we have to know. So, you have something we call the elements. If there is interruption, situational arrest, but it becomes early, please, right at the spermatogonial level. And remember, spermatogonia is after the germ cells, which is spermatogonia. If it doesn't develop beyond that, it's early maturation arrest. All right. The late maturation arrest describes the condition when the arrest occurs at the early spermatid stage. Remember, we said that at the early spermatid stage, what is the nature of the cells? Early spermatid stage. What is the nature? Who can tell me? Early spermatid stage. What is the nature of the cell? Somebody should bear me out. At the early spermatid stage, what's the nature of the cell? Oh, this one is simple. At the early spermatid stage, what's the nature of the cell? Let's call me there. Let me look at my people. At the early spermatid stage, what's the nature? My boy OT, you have OT, you have always gotten it right. So this time around, I want to see. Oh, OT, I thought you were bringing an answer. I said, hello, sir. No, I'm just calling you to give me an answer. That at the is saying that you are saying that the late maturation arrest describe the condition when the arrest occurs at the early of the cell at the early spermatic stage. Okay. At the early spermatic stage, the cells are rounded. Okay. So we are saying that at the early spermatic stage, the cells are rounded. This is where we are going to go to spermiogenesis, where the cells are now going to realign itself for the nucleus to move from the center to the centric, for the chromatin to be packed, to condense, and then the Golgi bodies will move to cover it. And when we talk about the protein DPY, which will be connecting the what do you call it? The Golgi bodies to the DNA, so that it gives you a good cap as an acronym and so forth. All those things will happen for it to now move from the round stage to the elongated stage. All right. Now, if you are doing semen analysis and all this, you are seeing a lot of round cells, round. We call them, these are immature sperm cells, round cells. Then it means that there's a maturation arrest. What is this type of maturation arrest? Yes, you can tell me. We do semen analysis, and you are seeing a lot of round cells, which are actually immature sperm cells. What type of maturation arrest is this? No. Danny, come again. Saying that you do semen analysis and you saw a lot of round sperms. These round cells actually immature sperm cells. They tell you something. In fact, they tell you that there is a maturation arrest. What type of maturation arrest are you talking about? That's late maturation arrest. Fantastic. Danny, come, that's good. You came earlier and now you got it right. Because we said that if there is an arrest or interruption along any of the path of development, it's maturation arrest. However, it can be early or late. If it's early, then the cells will not even pass beyond the spermatogonal stage. Okay, and that's where if you do histology, the pathologist will describe it as Sertoli cell-only syndrome, because let me see another answer coming up. Okay, late maturation. Good. So I'm sure now you are following the discussion that we want you to appreciate the fact that even if there is maturation arrest, by your knowledge, you'll be able to determine whether it's late maturation arrest or early maturation arrest. Now, with early maturation arrest, we are saying that the cells development are not even going beyond what we call it, spermatogonal stage. If they are not going beyond spermatogonal stage, are you expecting to get any type of cell in the semen? If they are not going beyond spermatogonal stage, can also see during storage stage. Yes, okay. So unfortunately, as lab scientists, we prepare the histology slides and we give it to the pathologists. We don't have, we are not into, but I'm just giving you the slide with you. If the reports come, you actually understand it. Okay, you are not, you are the lab scientist, you are the histology lab, you do all the tissue process, everything. There is testicular biopsy. You have done all your slides. Then when you finish, you go and give it to the pathologist. So what I'm saying that even when they have done that and they bring the report, you should be able to understand what it means. So if there's a Sertoli cell only syndrome, it signifies early maturation arrest because the cells development will not go beyond the spermatogonal stage. Okay, and so you never see even one mature sperm cell. The sperms are not developing beyond spermatogonia. So why are you going? Why you are not even going to see round cells? Because the round cells will get at the spermatic stage. Okay, but here you are not even going to get spermatids. And so all you are seeing are spermatogonial cells and then the germ cells. And so they report as Sertoli cell syndrome. In this case, this person, you will have no sperm at all. It is complete azoospermia. However, in late maturation arrest, the cells have been developed to the early spermatic stage, which are round cells. At the round stage, they are supposed to go to spermiogenesis, where there's going to be this realignment of the cell structure, where you are going to have the cell moving from round to become elongated. So you're not going to see elongated sperms, but you're going to see round sperms. That one, you can find them in the semen. You're going to, yes, you can get some of them in the semen. And that signifies late maturation arrest. But if you want, you can just describe as maturation arrest. But I'm just saying it's like seeing red cells in urine. Okay. You can say that you've seen red cells in urine, but if you can go further and say that these are red cells, then you know that there's a glomerular injury. That's all that you're saying. That yeah, you can say that there's maturation arrest, but you will now be able to know that what kind of maturation arrest we're talking about. This is late maturation arrest, because if it were not late maturation arrest, they will not even come out as round cells. Because early maturation arrest will stop at the spermatogonial stage. And at the spermatogonial stage, at the basal compartment of the seminiferous tubule epithelium. So they are nowhere close to the lumen. Okay, they are nowhere close to the lumen, so they will never be found in the semen. But those who are at the round stages, they are at the adluminal compartment. That's the compartment close to the lumen. And so some of them could be found in the semen. And in that case, you can comfortably discard them. Oh, yes. What about seeing elongated? When you are seeing elongated sperms, they are not maturation arrest. You see, you describe maturation as an interruption in the development from the germ cell to the mature sperm within that space. So once they have become matured, elongated, they cannot be said to be maturation arrest. I hope that point is clear. All right. All right, we will end here. God willing, tomorrow we'll continue. We're going to look at now you've seen the everything about the sperm. We're going to start to look at the structure and morphology of the sperm. We're going to look at the sperm structure, everything. So that once you go to all these things, when you do the semen analysis, it becomes simple. All right. Any question, please? All right. Thank you for your time. And I'm not too comfortable with the numbers these days. I don't know what is wrong. The numbers are not too encouraging. And people will keep on asking for the slides. If you don't attend lectures and you take the slides, it's like you don't take it like you have complied with the conditions of the course. So the course by the attendance, you are supposed to meet a certain minimum attendance record. So don't think that you will get the slides. If at the end of the day you compute the attendance and you don't meet the minimum attendance records, you still not get certificate. So please make sure that you are making yourself available for lectures. And to me, I'm sure that if you listen to me, sometimes you understand far better than you going to read the slides on your own. Okay. Once again, thank you for your time and see you tomorrow and good night. Vera, thank you. You were here very, very early, right from even before 6.
Yes, sir.
Thank you, my dear. Thank you.
All right. Good night, sir.
Oh, somebody, please. Somebody says cannot hear me again. I don't know whether is that the case now. Can you hear me, please, Danny? Even though we have ended, I thought we have ended. Is that right? But can you hear me? I'm here to sign off. If you can hear me. But we have come to an end, the end of, okay, thank you, Felix. We have come to the end of today's lecture. So there are two areas that confuse a lot of people. There's apoptosis and then maturation arrest. I'm sure you have gotten it right. Apoptosis is a necessary vital phenomenon that will ensure that spermatogenesis carried out in the right homeostatic environment. All right. On that note, see you tomorrow. Good night once again. Bye-bye.